I welcome you all to the Microsoft Azure Pakistan Community second meetup that we are hosting now in March 2022. And there are a few housekeeping rules that I would like to tell before we move on with our discussion. We plan to meet up online at least once a month on Saturdays, and the online meeting will be organized using Microsoft Teams, and the online meeting would be recorded and later recording would be uploaded to the Microsoft Azure Pakistan Community YouTube channel. And I would request you all to please mute yourself during the meeting. And the meeting would be around 1 hour to 1 hour and 30 minutes, depending upon how much time would be used by the speaker. And there would be 10-15 minutes for Q&A session in the end. And you should preferably write your questions in the chat window. There are a few URLs that would be interesting for you. We have a LinkedIn community. We have a community channel on YouTube, and we also are available on Twitter. And all these links are also available in the meetup session. And I will also put them in the chat box. There are a few code of conduct that we need to follow. Please be friendly and welcoming to the others. Please be patient and be thoughtful in how you communicate in person and online, and be respectful and inclusive. Be open and curious, and reach out to the organizer if there is anything that you would like to tell, or if you like to give your feedback. And today we are having Jonah Andersson, who will be telling us about the different patterns of Azure durable functions. So Jonah, now the stage is yours.
Yes, I was thinking, are we recording this session already? I was thinking for those that missed this.
That's right, the session is being recorded.
Okay, it's already recorded. Okay.
Yeah, it's already been recorded, that's right.
Let's see, let me just share my screen. Can you see my presentation?
Yeah, I can see your presentation.
Yes, thank you. Yes, so hi everyone. Thank you for joining us today or tonight at the Microsoft Azure Pakistan community with my session about Azure functions, Azure durable functions, specifically the different patterns of Azure durable functions. And if you're watching this session recorded, it will be published on the community's YouTube channel later on. So before I start, I want to share with you a bit about myself. So those who don't know me or see me in the community, I'm Jonah Andersson. I work as a software engineer and developer at Forefront Consulting. And outside my job, I also work as a Microsoft, outside my job, I also work a lot with the community, tech community. So I have a role or title as a Microsoft MVP for Azure. I'm also a certified trainer, a mentor. I volunteer to mentor young women in tech that needs help and guidance in the tech industry. And on my free time, I'm also writing my first book about Azure, which is what you see on the screen right now. And I'm also a community leader, one of the community leaders of Azure User Group Sweden, which is a meetup group that was started about a year ago, since the pandemic started. And I'm running this community with another MVP for AI, Håkan, who is located in Oslo. Very active in the community as well. So today I plan to go through a bit about what serverless is, what are the services for serverless in Azure, basics of Azure Functions, durable functions, and then the highlight of today's talk was the application patterns that will help us solve the problems, complex problems when it comes to writing serverless workflows, and they are good to know. And then I have a simple demo example. So if the time permits, I would like to show you some code and demonstration of my simple app. And then I will be sharing some learning resources as well. So before I start, I want to introduce or give you a story about the dining philosopher's problem. I have a background of studying computer science, and I also studied Agile System Development in .NET and Java. And when I was studying Java, my teacher, my instructor shared me about the dining philosopher problem, especially when we were learning about concurrency. And I thought I would share it because it kind of relates to my talk today. So the dining philosopher's problem, if you haven't heard it before, so the story was kind of like a different versions of it, but this version is that there were 5 philosophers who were sitting in a round table, and they have 5 chopsticks to eat. They have 5 chopsticks in the table, and they need, each person or each philosopher needs to have both chopsticks in order to eat. So they need the one from left to right, otherwise he or she cannot eat. So the problem that we see here in this simple philosopher's problem is that we see an example problem of deadlock, which we experience in programming these days, regardless of whatever programming language that you're using. And then, of course, if we talked about the physical eating itself, the dinner that they're having, if they're not able to use the chopsticks or the spoon and the forks, which we use in Asia, then it would be hard to eat the rice, for example, which they have in their table. So so deadlock is just a background. What deadlock is, it's just like being in the a crossing in the traffic. So if everyone doesn't follow any traffic rules, there will be a problem. And deadlock is something like that also in programming. It is a condition that the techterms.com define it, that it's a condition where a program cannot access a resource when it needs to continue. And this is the negative effect of deadlock. We get accidents in the traffic if you don't have the traffic rules. So my point in those 2 small stories about deadlock and the philosopher's problem is about really highlighting the problems that we face today, which is concurrency in programming when we have to run parallel tasks, racing conditions, and we also have problems that we need to solve in our programming, which is deadlock. And I believe in the Azure perspective or serverless world in Azure, I believe that Azure Functions can help us solve these problems. But first, we need to check what serverless really is. So serverless is very common topic these days. Many overuse it, but just to make it clear, serverless, as we all know, it's not really serverless. It just means that there's an abstraction of servers and infrastructures, and the cloud provider, such as Microsoft Azure, is helping us by taking care of those servers, taking care of the servers that we need to maintain. And as developers or IT team, we focus on our logic, our development. And because of that, developers that are working with serverless architecture, they actually focus more on their productivity because they only have to write the logic they need for the functions. And serverless also has a pricing model that's pretty common, like the consumption model, which means that you only pay as you go. and it's also known to be great when it comes to integration. So regardless of whatever the code base that your web application has, you can integrate it with internal Azure services within the cloud platform, or you can also go multi-cloud integration, or you can also integrate it with other external APIs, which is also part of my demo or example today. So here in Sweden, we like to fika. Fika is the Swedish word that we use a lot every day when we want to take a break and with our family, friends, or colleagues and have a good cup of coffee. We like drinking brewed coffee and something sweet, a Swedish sweet. So I want to share with you about the serverless Swedish fika comparison from monolithic to serverless. So a monolithic is like a layered cake where you have all the layers in one server or one infrastructure. You have the data layer, you have the web application layer, you have the business logic. So you have everything in one place. And the disadvantage of monolithic or on-premise, this type of architecture, is that if something goes wrong with the server, then your entire system will be down. So there's a disadvantage of that. And then you have to eat all the cake, of course, especially if you're eating it by yourself or save it for later. Just kidding. And there's also microservices. They are like cupcakes. So each cupcake has its own flavor, chocolate or vanilla, and they are small. And it's like also microservices that each service has its own purpose. For example, a microservice that handles customer management, and then there's another service that handles order management and retention management. So those are examples of microservices when it comes to development. And then these days also we have a trend of putting things into containers, just like cookies in boxes, that you have everything exact the same that you need. You can bring it with you when you're in the park with your family and friends. Just like containers as well, you have everything in a box. You put it in a container, and then it's easy to carry when you're deploying it, for example, or traveling. And serverless, what the topic that we have today, it's like candies that it's easy to carry with us, and just like also Azure Functions, it's easy to create. It's fully managed. You can create Azure Functions quickly, and it's light, and it's easy to learn as well once you get the grip of it. And the purpose and the point that I have from this comparison between monolithic to serverless is actually more about control versus productivity. So as you see here, the more you go to the left, which is the monolithic, we see here that we have more control if you have the traditional monolithic architecture, but we don't have so much productivity because we have to maintain the server, make sure that everything is working fine in that monolithic architecture. But on the other hand, as we move to the right, from left to right, we gain more productivity. For example, if we decide to have serverless or combining containers and serverless, so we as developer gets more productive because we don't have to worry about the underlying infrastructures. We trust our cloud provider to take good care of that for us. So why do we choose serverless in Azure? I'm focused right now in one cloud platform, Microsoft Azure. It's because serverless in Azure gives us developer velocity, which means, as I mentioned, productivity as developers, and we can build and deploy quicker. And then when we can build and deploy quicker, we can also boost our team performance because we have this platform that will help us manage without like contacting an IT support. Hey, I need to upgrade my my applications because I need more resources, I need more performance. With the cloud, it's fully managed. You take care of that. You can set up the auto scaling capabilities and configurations yourself. And cloud also provide us intelligent tools and monitoring tools that will help us analyze our applications for improvement or for problem solving or debugging. And of course, if you have your applications in the cloud, it also improves our revenue in the business, and also modernization and digitalization in the market. So if you have smart applications and modern applications, you have a good place in the market, especially in this modern days. So there are different serverless in Microsoft Azure. I'm talking specifically on Azure Functions right now, but just an overview to those that are new in Azure serverless. There are different services depending on the type of category. So there are the Azure Functions itself is for serverless compute. And there's also other services for workflows and integration. For example, if you don't want to write workflows in the code, you can also use Azure Logic apps for writing or integration, writing workflows with integration with other Azure applications or services like SaaS services like Office 365 and other event-driven services like Azure Event Hub. And there's also Azure Service Bus that you can integrate with Azure Functions. And there's a new service actually that Azure released recently, and it's called Azure Web Pub Sub. That is very good to use if you're trying to build real-time messaging apps or chat, for example, using WebSockets. And I recently saw a good video about Azure PubSub, which myself I wanna do more hands-on and learn more to create a chat app. There's a video on Azure Friday about that, and of course. Other categories are databases that you can set serverless. Azure SQL database, you can do serverless. Cosmos DB, and monitoring as well is available, and integrations with other IoT, AI, and machine learning and cognitive services. You don't have any questions so far, right? No, I hope no questions so far. Yes, we can take it later. Yes, so next is Azure Functions. So what are Azure Functions? So Azure Functions is one of the serverless resource in Azure, and it belongs to the compute category, compute service. And the heart of Azure Functions is that it's event-driven. And what's good about it is you only pay as you use, or it has a consumption model, and it's actually just code, your logic, and it's also the events and data. And the events that here could be as its description, it's event driven. So in order to start your function, you need to trigger it with something, an event. And one example of trigger that you can use is like a blob trigger, or you can use a timer trigger, or you can also use a Cosmos DB trigger, which means that if data comes in your Azure Cosmos DB, you can trigger your Azure Functions, or it can be your IoT device or your Event Hub also. So there are a lot of events triggers that you can use with Azure Functions, and along with it you work with it, or you code your logic with the data that you want to process in and out as parameters, depending on how you want it as an output. in your application. And then there's also durable functions, which is the extension of Azure Functions, which allows us to write stateful workflows in serverless environments. And the good thing about it is that you don't have to worry about the state of your functions because it does it for you. And that's because of the durable task framework, which is the technology behind durable functions. And you can code it with all the major languages that we have today, including C#, which is one of the languages that I code on my day job. And if you don't code C#, there are also other major languages supported. So what's the difference between Azure Functions and durable functions? So for me, I describe it as like Azure Functions is stateless, because when the Azure VM, where the Azure Functions are provisions, get restarted for some reasons, it won't keep the state. Unlike durable functions, it's known to be stateful. So for example, if you have a use case that requires your task to be stateful, regardless of the status of your Azure VM, for example, then it's good to use durable functions. So since it's used for stateful workflows, so they are not in concurrent, or they're not competing with each other. They're actually the same, except that they have different purpose based on what you need. And durable functions have like different types. So when you code it, you have to code like a lot of like functions in your solution or project. So there's the client functions, there's the orchestrator functions, activity functions, and there's also entity functions. So client functions, they are actually the starting point of your orchestration. This is like your trigger. Like for example, your blob trigger. This is how you kickstart your orchestration. And then, for example, if you have a blob trigger, your orchestrator gets started, and you would need to use or code your workflow in the orchestrator functions, depending on the type of pattern or workflow that you want to use in your task. And there's also activity functions, which is called by the orchestrator function. So activity functions, they are like the normal Azure functions that perform tasks as well. And the other type is entity functions, which are commonly used for durable entities. I will dig deeper into this as I go along in the presentation. So next is the orchestrator. So of all the types that I showed here, the orchestrator plays a vital role in your workflow when you're writing durable functions. It's because our orchestrator help us keep the workflow, but it's also strict. I call it strict. It's because it's deterministic, which means that you cannot just do what you want in your workflow. You need to design your workflow or your orchestrator to be deterministic. It's because the entire workflow that you write will be replayed depending on how you code your logic. So it needs to be deterministic. Otherwise, there might be some issues that will happen. I can share about constraints later on as well. So if you want to learn more about the orchestrator and deterministic APIs, which is what's behind this, the durable functions also, you can check out the information on the link that I have on the screen. So here's an example of a function app with a determined orchestrator. So this is the orchestrator. You write your workflow here, depending on the pattern that you choose or you use for your use case. And then it kind of like calls your tasks, your activities. But if you have this one, no, without durable functions, you just like have isolated Azure functions in your applications that maybe they're talking to each other in your logic, but it's you don't have control how they are called because the code is everywhere. And if one of the functions stops, it might affect the other one. So these are like a comparison example of having durable functions with orchestrator and without. And as I mentioned, orchestrator needs to be deterministic. So there are documented orchestrator code constraints, do's or don'ts that actually is available to read for Microsoft documentation, but I can show some of them. So here on the left are the don'ts. So examples of don'ts are like since random or GUIDs are not like fixed or deterministic, you have to avoid doing that. And then configurations or database connection strings, you don't write it on the orchestrator function. Blocking APIs like the concurrent like keywords that we use like sleep, run, delay, that's not allowed in the orchestrator because the orchestrator itself is like is doing that, like it's designed to be stateful. And don't create infinite loops, like a lot of like infinite loops in your orchestrator, because it will be replayed. So if you're calling a lot of tasks that's running in infinite loop, it might affect your, for example, consumption bill or plan. And so we need to be careful about that. And then since orchestrator needs to be determined, the current datetime is not also recommended to use. But anyway, there are solutions for that. So if you really need GUID, you can use, there's a method through the context called new GUID. And this is, the syntax is different depending on the language that you're coding with Azure Functions. And then there's also, when it comes to configurations and connection strings, you can pass it in your activity functions. So you don't need to do that in the orchestrator. And then if you really, as I mentioned, the orchestrator itself is already stateful. So if you need to like control it more, you can use the durable orchestration context. And there's a lot of method if you just if you click on the dot, and then lots of methods that comes in as an option for you if you want to control the flow. And then if you need to repeat a process instead of having a while loop or forever loop, you can use the method through the context, create as new, and call the activity that you're trying to repeat or want to call again. And datetime, if you need to have it in the orchestrator, there you can use the current UTC datetime method as well. So the patterns. So here are the patterns that we need to know when it comes to writing durable functions. So there are 6 known documented patterns. First one is the function chaining. Second one is the fan out, fan in, and then there's also the async HTTP API. There is the monitor pattern. There is also the human interaction pattern and the aggregator pattern. So the function chaining, as the word itself describes, it's like a chain of functions. So you have function 1 that passed in data to function 2, and a function 2 passed in data to function 3, so on and so forth. So it executes a sequence of function like a chain, so in sequence. And so this is my demo or example is about, and there are certain use cases that this pattern is useful, especially if you have something that you want to do that requires an output of something, an event or a task, then you can wait for that before the function starts to do what it has to do when it receives the output of the previous function or task. And the function chaining in action in the background, I created this illustration or animation myself as just to give an overview what it's really doing. So function chaining in action. So for example, you have a trigger, for example, a blob trigger. You uploaded the blob or an image to your Azure storage, and that kickstarts your orchestration. So when the orchestrator has started, your first activity gets scheduled, and then what it does, well, activity 1 is scheduled, the orchestrator sleeps. And when activity 1 is done with its task, the orchestrator wakes up, and then the next activity, which is activity 2, is scheduled, and then the orchestrator sleeps again, the activity 2 is done, and then the orchestrator is completed. This is an example where you only have 2 activities or tasks that you need to do in the workflow. So as you can see, this entire workflow will be replayed. So if you trigger again with a new blob that you upload to your Azure storage, the entire process will be replayed exactly as how you designed it in your workflow. And as you notice, the orchestrator can be a sleepyhead, like my dog. I have a Labradoodle dog, and it almost look like that, but more hairy. But it's good when the orchestrator is sleepyhead, because that means you're not paying for the activities or functions that are not running. So that's the good thing of durable functions that are stateful, because you have control of your workflow with the help of the orchestrator. So this is a simple example on the code from the Microsoft Docs for C# for the function chaining and hello sequence that outputs strings that's saying hello to different cities, capital cities, and just return it as a string, returning hello Seattle, hello Tokyo, and hello London, based on that, a simple one. And then the second pattern is the fan out, fan in, and this is a very known pattern as well to use if you have parallel tasks that you want to parallel tasks or multiple functions that you want to run at the same time, and you want to wait for all those tasks to finish, and then you want to fan in for the results. So this is very good pattern also to use if you have a use case that suits for that. Like for example, there are different examples. I will show it to you, but when it comes to consumption, they said, I read an article about it, they said that function fan out and fan in pattern allows you to save more money in the consumption plan compared to function chaining. Because when you function chaining, you have to wait for the previous function to finish. But sometimes if your use case allows it, it's nice or better to choose a fan out, fan in, because you can trigger it, and then you decide that to run all the functions in parallel, and then you aggregate the results. But it depends on what you're trying to solve. That's why I'm not so specific what kind of use case scenario you can use with this. So as I said, it's a good pattern to know. And here is an example from Microsoft documentation as well for C#, since I'm a C# developer. So here we see an example of an orchestrator functions that helps us back up a site content. So here we have, we just have a directory of where you want to get your document, and then you check if it's null or if it's empty or not. And then you look through the files, and every file that you have in your loop, you back up it by calling an activity called copy file to blob. And then when all of those tasks or copying are done, you actually use the task when all method to kind of like check if all of this is done, and then you return the, for example, the data like total bytes for that copying of a blob to that specific location. So that's an example of the fan out front in pattern. And then there's also async HTTPI pattern, which is common for long-running operations for external clients. So this is a good one as well if you want async HTTP API, which is not easy to do on normal functions. So you can check it out. You can use HTTP endpoint trigger for long-running actions. So this is a part of the things that you can use as well. I have a simple example here. So this is like an async method or function where I want to check if my website is available. So it's running stateful, and I have an orchestration trigger through the context, and I have a try-catch block. I have my URL for my blog or website, and I create an instance of durable HTTP response, and I use the call HTTP async. That's the method that you use in the durable context. And then you decide in the parameters if you want to do get post or other HTTP method, and then you pass in your URL. And this is just my website right now, but you can use an endpoint, for example, an API endpoint, to get the results of the data that you're trying to get. So in this example, I have like an if-else condition just to check what's the status of my HTTP response. And if the response is good, then I will kind of like log the content or process it further. Otherwise, I can throw an exception like the HTTP request exception in here. And then the next pattern is the monitor pattern, which is used for, as the word itself, it's for stateful monitoring. So if you have something that that requires a workflow or use case that requires to be flexible and recurring, then you can use the monitor pattern. And one example of this is monitor pattern, monitoring job status example, in which you have a while loop that has like a check. It checks through the context, the expiration time, and then you wait for the job status. And then when that job is completed, you're gonna send an alert, which is another task or another Azure Functions, and then pass in what machine ID is done with the monitoring, for example. And then you can have a durable timer here. For example, you want your orchestrator to sleep, so you can use the durable timer, where you can use context create timer so that it checks when it's the next time you need to do it in your while loop. So yeah, that's monitor pattern. And then there's also a human interaction pattern, which is good to use in use case scenarios where you require a workflow that needs human interaction. So one very simple example of this, or common one, is approval request scenario. Like, for example, you have something, a document, for example, that you want a person to approve. So you can have a function that sends requests for approval, and then you can have two things, a person, a response, external event from a person, a response. And if that person responds, then you process the approval. But if that other person, you kind of create like a durable timer. So if that person doesn't reply, for example, within 24 hours or 48 hours, you can create a durable timer in parallel. And escalate or do another task to escalate it further. That might be a logic in your escalate that you want to send an email to another colleague of that person that's probably on vacation. So this is a good example of a human interaction pattern, a pattern or workflow that requires human interaction, but you can use with durable timer as well. So that's how the approval workflow works in the code. So the most important, I think this is something that you can see also in the documentation, but I want to highlight the special one. So here we have the durable timer, so which uses the context that create timer, and then you set your timeout time. And here is the most important one. You have the approval event, which wait for external event, and that is the response from the human being or from the person. And that approval event can be like, for example, if that person responsible can reply to SMS or reply to email, when that gets triggered, then you can process it further with a process approval. Otherwise, you do the escalation logic. And the last pattern is the aggregator pattern, which is used for stateful entities. And I haven't worked it a lot myself, but it's commonly used for stateful entities. Like, for example, if you want to aggregate data over a period of time, certain time from different resources. So these data or hours that you see here, they can be data from different resources, and anytime they can come in to your Azure Functions. So this is not easy to do if you have like a function up that's not stateful. So this one is good if you have like different data from different resources that can come in anytime. So you can aggregate it and process it with stateful. That's why it's called stateful entities. And it uses the durable entities in parallel as well. So you can check out the documentation about that on the Microsoft Docs as well if you're interested to dig deeper in the technical aspect of it and start coding. And aside from the 6 pattern that I mentioned, there's also sub-orchestrations in durable functions, which means that you can create an orchestration within the orchestrator. So here you see the starter, your durable client, and then which kickstarts your orchestrator. But your orchestrator has 2 sub-orchestrators, so you can do different tasks here and then different set of tasks here as well. So this means that the pattern that I shared, they are just like the documented pattern, but through sub-orchestration, you can actually create as complex a pattern as you want, depending on how you want to like solve it using durable functions. So here is the example, simple example of sub-orchestration code in Microsoft Docs. It's like provisioning new devices. So here we have a loop, for each loop that goes through the list of device IDs. And here you have a method through the context called call sub-orchestration async, and then call that activity, pass in the device ID, and then when it's done, it's gonna it's kind of like combining the fan out, fan in using the when all method for all the tasks that was processed. So now with developing, so when you're developing Azure Functions, those are the things that you can use. You can use the Azure portal, the Cloud Shell, the Azure CLI. And when it comes to local development, you can use Visual Studio and VS Code as well. And you would need to install the Azure Functions core tools in your computer. And if you're working with HTTP related development with Azure Functions, it's good to have Postman or anything similar. And for Azure Storage, for example, I know that you can access Azure Storage online on Azure portal, but there's also a software application version of Azure Storage Explorer that you can use for local dev, which you can access locally. And every Azure Function app or Azure Function app has a connection or association with Azure Storage. So you cannot create an Azure Functions without setting up your Azure Storage. That's good to know. That's an important thing because in Azure Storage, that's where your web jobs or your logs are saved in every instances that you access or do in your orchestration or in Azure triggers, for example. So it's good to know that there's a local version or application for that as well if you work locally. And then the languages supported C#, Java, PowerShell, Python, TypeScript, and I think there's also Go and Rust also. Not many examples, but they're supporting a few of them as well. So full stack development with Azure Functions is possible with Azure Static Web Apps, and it also has support for API support in which you can use it with Azure Functions built in. Or if you already have an existing Azure Functions that's published in production or Azure, you can also use the option bring your own functions as well. Let me just drink water. So bring your own functions as well. So this is how it looks. For example, you triggered your orchestrator with a blob trigger. So when you access it, behind the orchestrator, you get like a orchestration instance ID, and that is something that's good to have, especially if you want to restart or control the orchestration instance that you currently have. So for the orchestration instance details, you have the ID of your orchestration, the instance ID. Then you also have the URL of your instance, and then you also have the option to raise event URL, to terminate if in case of you're trying to debug something, what's wrong, and it's kind of like, for example, by accident you wrote an forever loop in your orchestrator, you want to terminate it, then you can use this URL, these details in your orchestration instance to terminate it. So as you can see, I have localhost because I was working locally then. And then you can also purge history, and then you can also restart your workflow manually if you need to. And coding durable functions, just want to share the good to know and good to have. For monitoring, you can use Azure Application Insights. That's part of Azure Monitor. And then when you're updating Azure Functions or durable functions, it's good to have conscious versioning, side-by-side deployment, and deployment with breaking change. I know that many are having, like, it's not easy to just update an Azure Functions just like a standard web app, because they're like stateful already or running in production, so you have to do conscious versioning and side-by-side deployment if you want to make updates or changes. And Azure Storage Explorer, good to have, and you can also use deployment slots in Azure Function App. And for security of your connection strings, you can integrate it, Azure Functions with Azure Key Vaults, Azure Configurations, and even with Azure AD or Identity. You can also do that with Azure Functions. And as for error handling, so one of the common exceptions that you get is the function failed exception. And in order to handle it, you can actually, there are several ways to kind of like handle it before it happens. So what you can do when you get this exception is you call another function activity. You can do the automatic retry on failure, which is a feature in durable functions using this method. This is specific to C#, this method, but it might be a different syntax on other language. And then try catch block, our standard like error handling favorite block. And then there's also durable timer, just like the human interaction pattern example, that if the human or the person that's responsible to do the task through the external event doesn't respond, then you can have a durable timer, so you have control of your workflow. And then you can use application insights and durable functions monitor as well. Okay, let's see. This is an example of automatic retry in durable orchestration context. And then this is an example of try-catch blocks as well. Let me see. Wait, let me just wait a moment. Ah, I couldn't see. I had to like cough a bit because my my throat was dry. Sorry about that.
No problem. You're talking for quite a long time.
Yeah, I was talking a long time, so I have to drink water in between. In other words, wait. Let me see. So this is an example of try catch block for error handling. So this is where, for example, you want to transfer funds and you have a try catch block to handle if the credit or the transfer of account doesn't get processed. So you can do an exception by calling another activity, for example, credit account. And then you do like transfer back the account to the source account, for example. And then unit testing is also possible with Azure Functions or durable functions. So you can unit test by activity, or you can also unit test the orchestration itself. So you can mock it this way. So there are examples of that in the documentation, how you can unit test it. And as for unit frameworks, you can use the common ones that we have used in development, like mock or XUnit, for example. And the deployment CI/CD for Azure Functions, it's also the typical ones, like you can deploy it on an Azure Function apps on Windows or Linux. You can also deploy it on a container, and GitHub Actions works also pretty well with Azure Functions. And then infrastructure as code ARM templates, that's also like doable with serverless functions and container registry. And if you really need to use this pub XML, that's also an option when you publish it. And then serverless containers. I know that I spoke about monolithic versus like up to serverless and containers. So you can use Azure Container Apps as well if you want to have a fully managed container service that's also serverless. So this is a new service that Azure released, I think, in the recent Ignite, and it's currently in preview, which means that you get a few examples, but it's not official yet, or GA version yet. But what's good about this, this is built for microservices that help us, or if help use cases if you want to handle HTTP traffic events with long-running backgrounds, for example, and if you need to integrate it with Dapper and Kada as well. So it's good to know. That's why I added it on my presentation. And if you want to make sure that you're running the right version of durable functions or Azure Functions, there's documented like supported languages. So you see here, for example, there are currently there's up to versions 4 of Azure Functions. That's the latest. So for C#, for example, if you want to code .NET 6, then you would need to have version 4 of functions, and .NET 5 and Core, it should be at least 3 version. And then it's also, there's a table of that depending on the language that you're coding. And here is like the roadmap that Azure has for functions in here. So we currently we're in .NET 6. So that's recently. So when .NET 7 arrives, there will be Azure Functions for isolated process, and also .NET 8 when it's coming. So it seems like the .NET world, it's so speeding up with a lot of things, and we need to catch up. I haven't like started like coding a lot with .NET 5 and 6, and then .NET 7 is coming. So it's pretty quick, but it's good to know. So if you want to learn more about it before you get started, it's good to know based on the language that you're coding. So feel free to check it out. And then I also want to share about serverless when it comes to security, because I know that many are conscious or concerned about security when it comes to serverless architecture or serverless workflows. It's still a challenge, and I know that security teams in Azure are also trying their best to fix it or to control it in a way. So I want to share about Cloud Katana by Roberto Rodriguez. So it's personally, I had in contact with Roberto with this project because he used durable functions to make this open source project, Cloud Katana. So what it does, it's like it's an open source project that simulates the attack within Azure. So if a hacker tries to hack Azure through Azure AD, so it kind of like simulates it in a way to find out what the hacker is trying to kind of like get from a user through the IDs that you have, like subscription IDs and stuff. So I cannot explain it in details, but this is the architecture it looks like. In my part here is to help Roberto with the durable functions part, but I know that it will be coded in different languages. Currently it's in PowerShell script. So, and this architecture. But if you want to learn more about it, it's on this link, and you can check it out for contribution if you're interested to contribute as well. It's an open source one. And before I finish, maybe I don't have time to show the code, but I can show you my demo. So my demo example is like I have a serverless function chaining example. This use case, for example, you can have an image uploaded to an Azure blob, Azure storage, which triggers an Azure blob trigger, and it starts the orchestration. And then when the orchestration gets kick-started, I call in my first function message. My first function, which is to send a message to Service Bus in Azure. And then I also have, and when I'm done with that, I can send SMS or call via Twilio API. And then I can also send email using SendGrid. So I have that repo on GitHub, so I can maybe post it on the chat later after the session. And then the expected result of that example is that I will get an SMS, I will get a call, and then I will also have the queue message in the service bus, and I will be receiving an email. So I'm not sure. Maybe I should, is the time still okay, or maybe I don't have much time now?
Yeah,
I'm about to end.
You still have time, no problem. Take your time.
Yeah, so I think I will show you my demo code. It's just like I want to run it or something. Let's see. So that's my code, and this is my like storage. Let's see. Storage. And I also have like a list of images here. So let's see. Can you see the Visual Studio here? I hope so.
Yeah, it's visible. It's visible.
So just one briefly before I start showing or running this code. It's just a simple function chaining example that I showed you where I have a blob trigger, which is my client function, the starting point of my orchestration. So I have my connection string locally, since I'm working locally right now. And then the name of my container, Azure Storage Container, is called Photos Container. And in here, I just check if the blob is empty or not. And if it's not empty, I'm gonna start use the method called start new async, which calls the orchestrator. And my orchestrator is this one. It's called serverless Azure Storage Orchestrator, which has the iDurable context. And from the context, I can get the input. This is on line 23 here. From the context, I get the input, which is the Azure Storage, blob, and then save it in a variable called uploaded cloud blob. And in my orchestrator, I have my workflow here, like a few series of workflows. So if my first chain is, I'm gonna call the activity send message to service bus, and if the result back is not empty, I'm gonna send SMS or call user using Twilio. So I have another activity here that's called send SMS call to Twilio, and passing in my service bus message. And then when I'm done sending SMS and call, it's gonna like send an email notification. And the logic for each activity is in here. So maybe I don't need to describe in details, but you can check it out in the repo or GitHub link. But let me start this one. Let's see. I hope I can put everything in one screen, but let's see. So this is my Azure Functions. Irani, this is in core right now. In my images, and then I have 3 screens. So I have to I have to like try to put everything in one screen. So for example, let's see, I can do it like that, and I can just drop. So here, let me prepare my phone. So for example, if I'm gonna like drag and drop demo photos, number 1 to my Azure storage. Did it? So, oh, it went quick. So it's processing it right now. And at the same time, I'm getting a call from Twilio. And it went too quick. That's just like seconds. They say a new cloud blob demo photos was uploaded to your Azure storage and your service bus queue. So if I'm gonna open my Azure right now, for example, I have my that was my email. So I have my storage account here. Let me just see. My service bus, let me just check. This is my service bus. And if I'm gonna go to my queues and service bus explorer, let's see. And I'm gonna do like peak maybe. I had messages there already earlier, but if I'm gonna do a peak of my recent messages, here we see, let's see, sequence number 49. It says here that I have a message saved from the service bus today, exact as of this moment. And it has this message. It says like a simple message that I saved here. So, and I believe I also got an email and SMS. So this is just a log in here. So that's this simple, very simple example or demo. And I'm glad my live demo works. Sometimes it crashes. So now I got SMS as well. But that's the expected results in the kind of mini demo. And if you want to learn more about Azure Functions, durable functions, there are a lot of great resources in Microsoft Learn. And there's also Azure Functions on Twitter. They're very active in posting updates. And there's also a friend and another MVP in Netherlands. His name is Mark Duker, very active in sharing about Azure Functions through his channel called Azure Functions University. And there's also a few examples in the Azure Serverless community library if you just want to check what you can do with Azure Functions and some examples there. All right, and also I wrote a blog a year ago and it needs updating, but I wrote the basic or fundamental concept about durable functions on my dev community blog. So if you want to read it, you can scan the QR code. And also I want to recommend about one of the events that Norwegian.NET User Group Oslo has recently published. It was a talk about event sourcing, and they mentioned about serverless and event-driven architecture there. I recommend you to watch that talk. It was an in-person event that was recorded, so you can check it out when you have time. You can scan the QR code, or I can share the presentation to you if you need a copy of it or the links. And also, I'm a community leader as well, and I also run communities. So I have a community group called Azure User Group Sweden. And if you are interested to join one of our upcoming events, which we will have next Saturday, we will have someone speak about Azure Static Web Apps. So you're welcome to join us as well. It's a live event. And then after the event, we usually have like a FaaS session where you get a chance to speak with us in person, live virtually on Zoom, or even get a chance to ask direct questions to the speakers. So feel free to do that. And if you are someone who has something to share about Azure, feel free to be one of their speakers, regardless if you're an experienced speaker or a new speaker. Feel free to just submit your session and join us, because this community is for everyone and it's inclusive for everyone. So it's also virtual. All right, so I want to end my session by showing this. So I want to say that as a developer, I love serverless because I can solve complex problems, I can build modern apps, and it makes me productive. All right. Thank you so much, everyone, for joining me. And I apologize it took a few minutes later, but you got to see my demo.
Thank you very much, Joanna, and it was really, really informative, not only for the .NET programmers, C#, Python programmers, but also for Azure administrators like me who would be provisioning the serverless function and also the Azure functions.
Yes.
I don't see any questions in the chat window, but I do have two questions related to durable functions.
Yeah.
I have one question related to the orchestrator functions.
Yeah.
And as you can see, orchestrator functions are like they would be running all the time. So what if what if there is some kind of either reboot on a machine, on a virtual machine, or some kind of wait that could result in the local loss of data in the local state, or it will never happen?
You mean errors that can happen in the durable functions, or when
Yeah,
you're working locally or on Azure when it's
that's right.
hosted?
Yeah, that's right. That's right.
You mean locally?
Locally, that's right. Yeah.
Yeah,
And
that's right. Yeah, there's a common problem with Azure Functions. I mean, it's good, it's great that you can develop locally, but it happened to me one time that I was working with Azure Functions or Durable Functions, and I was supposed to do a demo, and it didn't work. It's because of my computer stopped. It something happened in the background with my durable functions that caused it, because one of the issues or common issues with Azure Functions is the issue with cold start, especially if you have consumption model or consumption plan. But to handle it, I think it's good to there is a tool called Azure Rate that they said that it's better than without using one. So that's a good example that you can use locally. But there is also another way for you to handle local issues like that if it takes long time, aside from stopping it, is to kind of like check you adding logs. Because in the code that I showed, when you create a context, there's like a log that you can use iLogger if it was .NET to log everything that's happening in your context as well. And everything is also recorded or logged in the Azure storage on the web job. So when you create the function, you can connect it to either an Azure storage that you already built in Azure, or you can have it in your local storage, but you have a way to control that as well. But it's not so common, actually. Once it's published, I don't see a lot of issues of that except working locally. But as far as I know, it's been working fine locally for me, unless you have a lot of tasks to do maybe, or like data that you need to process, and maybe the computer couldn't handle it locally. So yeah, it depends.
yes, and the other question is related to the durable functions billing.
Yeah.
Because orchestrator functions, they do incur a replay billing when they are executed second time, third time, fourth time. But do you think that there is no double billing in case of orchestrator functions, especially when you are also using like sub orchestrator functions like this? This is just for me from an Azure administrator point of view.
No, actually, because if you create a durable function, it's like it's in your function app, and there's only one subscription or billing connected to your resource group in that. So I don't think it will affect it that way. But the only thing as a developer that you need to think is how you design your workflow, for example. So you have to make sure that, as I mentioned, the constraint, that's why it was really important for me to share in this presentation about the code constraints that Microsoft Azure Functions teams really publish, because as beginners, for example, even regardless if we're experienced developers in languages that we code every day, but if you're new to specific technology like Azure Functions, you didn't know about the constraints and you just code your logic the way that you usually do, and you didn't know that the orchestrator itself repeats itself, and that can also affect the billing if you're not conscious about it. So I think as an IT administrator or Azure administrator, you don't have to uh, think about it, but I think as developers, they have responsibility. Yeah, I'm a developer as well. There's a responsibility there that you are conscious also about what you're doing when you're developing, that it doesn't affect the business, because it will show also. First time you do it, it will show. But they said that using fan out and fan in pattern is useful to save money with the consumption, and also using sub orchestration as well. And it's kind of like, it depends on how you author your workflow.
Okay. Yeah.
Yeah. I hope it answers your questions. Maybe not so clear, but explains maybe.
Yeah, I mean, I think it's perfectly fine. This area is also very new.
Mm-hmm.
So, and there are some areas in this where we need little bit more clarity from maybe from Azure, in terms of especially related to how the billing associated with the function can be maintained.
No.
And I don't see any further questions in the chat window.
Yes. Okay.
So let me know if there is if there is anyone who would like to ask any question. This is your chance.
Yeah, if there are any questions, they can also contact me after the session for follow-up. And if there's any of you that wants to have a copy of my presentation or the GitHub repo example, I can also share it with you, Sarah, if you need it, share later on.
Yeah, that would be really good if you can share at least a URL for the GitHub repo, because that would really help, especially those people who are interested in coding.
Yeah, sure.
Yeah. Anyways, Joanna, it was really, really good to have you on this forum, and your presentation was very informative. And I hope you will also give us time next time.
Yeah, sure. I sent the repo on the chat right now. It's a starter. I created a starter template of my demo. So those developers that wants to get started, try it out, they can just set up their storage account, service bus, set up an account, free account in Twilio and SendGrid, and then they can just fill in the local settings or the host settings if it's ready to publish. So you can kind of like add it as a template. And if there are any issues, you can create one in the repo so I can fix it. It's a project, mini project that I'm just doing on my demos, for example. But thank you so much, Usair, if I pronounce your name correctly, and your community for having me today. I'm glad that you gave me a chance to speak.
Thank you so much, Joanna, and thank you to all the people who have attended this presentation. This presentation would be uploaded to our YouTube channel. And with this, I will say goodbye to everyone. Have a nice day, nice evening, wherever you are. Thank you so much. Bye.
Thank you so much. Bye-bye.
Bye.
Bye-bye.